Hello, today I'm going to show you the configuration tool for the BeagleBone Black. This is the tool that can be used for the creation of the capes and the configuration of the capes. And what you see here is basically this whole thing right here is equivalent to this part 8, as you see. And this is part 9. And now if I want to configure something, let's say I want a pulse width modulation, I can just search for a pulse width modulation here, and this would be one of them. So I can select the pulse width modulation. I can select if I want the input resistor or not, and I say output, so there is no input resistor. I can say, is it a pull up or a pull down? Is the pull even enabled or not? And the slew rate also can be set. So all the configurations that are possible for the pin, you can make them here. So going to unsearch that, and you see this yellow color for the pin means that this pin has now a configuration put in the tool, which doesn't mean that the configuration is loaded in the slots. The slots file is where you see all of the capes that are currently loaded in your BeagleBone Black. So if I now say I want to load this configuration in, I just click Finish, and takes a second. There we go. This color here right there means that there is now a configuration, and you see it's in the slots. This is a configuration that's currently loaded. So you see this already works. Yeah. I can also say I don't want to use the pin anymore, and I can just click on unclaim, and the pin is free again. So the configuration is no longer loaded in slots here. Yeah, as you see, it's gone. So I can make an entire cape here by just clicking on the individual pins that I want to use with the modules that I want to use. Let's say I search for a UART. I can just say I want to use the UART that is right here. EXD. There. Yeah, the red color means that there is no device tree overlay file for the configuration. So if I wanted to use a configuration that is not yet in those firmware files here, I would just have to make another device tree overlay file, and with the correct configurations, then I can load those too. So I say this one input. Yeah, okay. Yeah, and now the UART would be here. So then I say I want to use a, I don't know, let's say, what else could I use? I could use a can, for example. Yeah, here. There's a can. Where is it? Can there. And here's a can. This one is an input, pull up. This one is a pull up, and input. No, output. Yeah. So yeah, you see that those configurations are valid for this board, and I can again load them in the slots if I want to, or if I say I want to create a program that is using this UART and those can pins here, then I can say I just save those configurations. So I call it can and uart in auto config file, and I save it. There we go. Now those configurations are saved in a file. I can load them later. I can just demonstrate it real quick too. Load nothing. And all pins are free again. Now what did I call it? Can and uart. And I load it, and there we go. It's back again. Yeah. So I can make an entire configuration for an entire cape, save it, to later use it in a program, load it in a program when I run it. Like in the initialization of the program, I can just run the configs, see if the configs have been loaded correctly into the slots of my cape manager. And if that's the case, then I can proceed with my program without any concerns whether or not it's correctly configured or not. And I can do all of that during runtime when the board has already booted. And yeah, so you can change configurations on runtime without even fiddling around with the hardware. You don't have to use the cape manager EEPROMs to do it. You can just load those configuration files, and it will configure everything according to your need. So yeah, if you have any questions, you can just ask them in the comment section, and I'll see to it that I answer as many as I can. And yeah, that would be the configuration tool. Yeah. Thanks for watching, and goodbye.